everyone. So today we're going to have a new topic on influence lines. Okay, so let us define first what are influence lines. Okay, so as per this definition, an influence line represents the variation of either the reaction, shear, moment, or deflection at a specific point in a member as a concentrated force moves over the member. So as you can see from the figure or from the picture shown here, so para you can see here a bridge wherein a train is passing by. So influence line is actually a diagram, or it could be a graph wherein you could see the variation of the reaction. It could be a reaction, or it could be a shear, or it could be a moment at a specific point due to a varying location of a unit load. Okay, so from this definition also, an influence line is a graph of a response function of a structure as a function of the position of a downward unit load moving across the structure. So let's say I have this simple beam, ABC. Okay, so I'll be passing through a unit load. So this is the unit load. No? So 1, a concentrated load. So I'll be passing or I'll be putting this concentrated unit load from point A to point C. So as the unit load moves from point A to point C, the reaction at A varies. So yung influence line, that would be the diagram that will show us kung paano nagbabago yung reaction sa A when the unit load moves from A up to point C. However, if we're asked about the influence line for the support reaction at C, that influence line for CY, that would be the diagram that would show us the variation of the reaction at C due to a moving unit load from point A to point C. So to illustrate that, so this is how we do it. So yung figure A, so this is the given simple beam of span L. Then we apply this unit load over here, and the unit load is located at X distance from point A. So therefore, the X distance varies from 0 to L. So what would be the reaction at A as the unit load moves from point A to point C? And that would be the influence line for the reaction at A. So this which is shown here in figure letter B. Okay, so as you can see, this is influence line for A sub Y, or this is the influence line for the reaction at A. So as you can see, at X equal to 0, the reaction at point A when the unit load is at point A is equal to 1. And as the unit load moves from left to right, as you can see from the influence line diagram, okay, so the reaction decreases from 1 to 0.75 to 0.4 up to 0. So this influence line shows us the variation of the reaction at A when the unit load moves from left to right. So meaning to say, kapag ka nagmo-move yung unit load from left to right, yung reaction sa A decreases from 1 to 0. While on this figure letter C, this shows us the influence line for CY, or the reaction at C. So as you can see from the diagram is varies linearly from from this point 0 up to 1.0 over here. So this means that as the unit load moves from left to right, the reaction at C increases. Okay, so that is what influence line means. Okay, so to fully illustrate how to draw or how to make the influence line, so let's have this example. Okay. So let me share my screen in the next example. Okay, so for this example, we're asked to draw the influence lines for the vertical reactions at supports at A and support at C. At the same time, influence line for the shear and bending moment at point B. So as shown in the figure, point B is 12 feet measured from the hinge or point A support of this simply supported beam shown in the figure. So usually, yung influence line is applicable for bridges. Kasi as we know, diba, yung mga bridges are, when we design bridges, we consider moving loads. Okay, so and usually ang bridges are idealized as simple beam. Okay, so kaya kadalasan, ang application nito would be for simple beams. Okay, let's say for this example, the span of the simple beam is 20 feet. Okay, so let's try first. Okay, so let's try. Okay, so let's start with the influence line for RA or the reaction at A. Okay, so how do we do it? Okay, so let us copy the beam. Okay. Okay, so let me copy this beam. So we have this beam here. Okay. Okay. So influence line for RA. So that means we will be considering a unit load. Okay. So let us say that the unit load is here. That is 1. And let me define that unit load at a certain distance from A. And this would be the distance, say X. Okay. So first is we have to solve for the reaction of the simple beam. So of course, it will have reaction at A and reaction at C. Okay. So let us solve for the reactions. Okay. So if I say summation moment at A equal to 0, so what are the moments? So we'll have 1, the unit load, times X, that is clockwise, so positive. Then the reaction at C, this one. Okay, so that would be negative RC times the distance is 20 equal to 0. So from there, we could say that the RC or the reaction at C would be equal to X over 20. X over 20. So this is X over 20. Now, so if we sum up forces vertical equal to 0, so that would be RA. So we have RA here. So RA plus RC. RC is X over 20 minus 1 equals 0. So therefore, we could say that RA is equal to 1 minus X over 20. Or we could say that RA is equal to, say, common denominator is 20. So this would be 20 minus X. Okay? So RA is 20 minus X over 20. Okay, so as you can see, the RA and the RC are functions of X. X is a variable which ranges from 0 to 20. Okay? Okay, so next. Okay, so what we're going to do is to draw the influence line for RA. Okay, so what we're going to do is let us set ranges. Okay, so when X is equal to 0, what would be the reaction at A? Okay, so when X is equal to 0, substituting 0 of X in the equation for RA, so this would be 20 minus 0 over 20. So that would be 1. Diba? So 1.0. 0. Okay, so what else? Let's say x equals to increment of 5. What about when x is equal to 5? When x is equal to 5, so substitute your x here. So our RA would be 20 minus 5, which is 15, over 20. Or that would be 3/4 or 0.75. Okay? Now, what if x is equal to 10? When x is equal to 10, substitute it here also again. That would be 20 minus 10 is 10 over 20. So 10 over 20, or that is 1/2, 0.5. So again, when x is equal to 15, again, substitute the x here. The RA would be 20 minus 15 is 5 over 20. And that is 1 over 4. 1 over 4 is 1/4 or 0.25. Then what if at x is equal to 20? X equals to 20, that means the unit load is at point C. So substituting x equals 20 on this equation for RA, it would be 20 minus 20, 0 over 20. So that would be 0 over 20, or that would be 0. Okay, so when we plot this, okay, so let us plot this one here. Okay. So this would be the influence line for RA. Okay, so this is the influence line for RA. So at x equal to 0, so nasa point A yun, diba? It's 1. So let's say, nandito siya. So nandito siya. Okay? Tapos at x equals 5, 10, 15. So let's say, hatiin natin siya in 4. So ito yan, no? Ganyan. So this is 1. Okay? When x is equal to 5.75. So nandito siya. Okay? So this is 5. This is 5 feet. 5 feet. 5 feet. No? Tapos at x equals 10, andito to, the RA is 0.5. So maybe somewhere here. When x is 15, so andito siya, it's 0.25. So maybe somewhere here. Then last, if x is equal to 20, our RA is equal to 0. So it's something that there. So if you will draw, or if we will plot those points, we will connect those points, most likely, it would be a straight line. It may be something like that. So, ibig sabihin, at x is 0, 1 siya. At x equals 5, it's 0.75. So, ito yon. No? So, this is 0.75. At x equals 10, ito yon. It's 0.5. At x equals 15, ito yon. And that's 0.25. And at x equals 20, and dito yun, so 0 yon. So that is now the influence line for RA. Okay? So as you can see from the influence diagram, parang nakikita nyo dyan kung ano yung changes sa reaction sa A kapag kayong unit load nag-move from point A to point C. So ibig sabihin, when the unit load is at point A, the reaction sa A is 1. When yung unit load napunta sa 5 feet, the reaction at A is 0.75. When the unit load moves at 10 feet, the reaction at A is 0.5. When the unit load is at 15 feet, the reaction at A becomes 0.25. Then when the unit load is at point C, nasa dulo, at 20 feet, the reaction at A pa rin is 0. So, yun yung ibig sabihin ng influence line. So, pagka nakikita nyo yung influence line, it could give you an idea ano yung mga variation, yun nga, variation dun sa reaction due to a unit load moving from within the span of the beam. Okay? So, again, that is the influence line for RA. Now, next question is influence line naman for the vertical reaction at C. Okay, so let's have C naman. Okay, so we're done with the influence line at A. So this time we're going to have, let's call it as for B, influence line for RC naman. Okay, so okay, tiba yung RC natin. Na-solve natin yung RC as a function of X is X over 20, yung reaction dito sa support roller C. Okay, so gagawa lang tayo ng ganun din, no? Nung at X is 0, what is the RC? Okay, so when X is 0, using this equation, RC would be 0, diba? 0. When X equals 5, so gawin natin increments of 5 uli, no? Kasi 20 feet yun, so increments of 5. So kayo na bahala mag-designate ng increments of X. No? So pwedeng by 2, by 5. Okay, so para ma-trace nyo lang yung influence line. So for this case, since 20 feet yung span, so 5, 10, 15, 20 na lang. So okay na rin yun. So 5, 10, 15, 20. Okay, at X equals 5, so substitute natin dito. X equals 5, so that would be 5 over 20. 5 over 20 is actually 1 over 4. 1 over 4 is 1/4 or 0.25. When X equals 10, so that would be 10 over 20. 10 over 20, or that is 1/2 or 0.5. When X is 15, so 15 over 20. Okay, so that would be 3 over 4 or 0.75. Then when X is equal to 20, so 20 over 20. 20 over 20, so that is equal to 1. Okay, so if we draw the influence diagram, so looking at the given figure pa rin tayo magbe-base. Okay, so let's say andyan siya. Then no, so ipo-project ko lang siya from sa taas pa rin. Okay, let's say ito yung zero line. So the influence line would be again at X equal to 0. So lalagyan ko lang siya ng division. So say ito yung 5, 10, 15, 20. Okay, so at X0, 0 ang RC. So andito siya. At X equals 5, 0.25. So nandito siya. 0.25, tapos ito 0.5, ito 0.75, tapos ito yung 1. So if you will draw the influence line, most likely it would be something like this. 0, parang ganyan. Na? Okay, so ito yon. At X0, RC is 0. Parang, okay, sorry. So ito yung RC. Okay, ito yung X. Okay, so kanina ito yung RA, no? Tapos ito yung X naman. So dito, X0, 0 din yung RC. At X equals 5, it's 0.25 here. At X equals 10, it's 0.5. And at X equals 15, it's 0.75. And at X equals 20, it's 1.0. So yan naman yung influence line para sa RC. So as you can see, when it comes to reaction sa C, lumalaki ang reaction sa C habang gumagalaw yung unit load from left to right. Palaki yung reaction. Samantalang doon sa RA, okay, if the unit load moves from left to right, bumababa naman yung reaction sa A. Okay, so yun yung ibig sabihin ng influence line for support reactions A and C. Okay, so I hope you have learned out of this simple example. Again, what I'm showing here is the influence line for reactions. So on my next video, I will show you how to draw influence line for shear and momentum. Okay, so thank you.